So this one, we want to construct the equation for this rational function. So what do we see? I have a vertical asymptote at x equals -2 and at x equals 6. X equals -2 and x equals 6. Now, what kind of asymptotes are they? What's the multiplicity that we're dealing with there? Well, you see it going up on one side, going down on the other, so that's multiplicity 1. Decreasing on one side, increasing on the other, multiplicity 1. So in both cases, those will be multiplicity 1 asymptotes. And again, vertical asymptotes make the bottom 0. So if x equals -2, that means x plus 2 is 0. If x equals 6, that means x minus 6 equals 0. So in terms of my rational function r of x, I'm going to start with x plus 2 to the first power downstairs and x minus 6 to the first power downstairs. Now, what other information do I have about this? I have x-intercepts, an x-intercept of 3, 0, and an x-intercept of 1, 0. Three, 0, and 1, 0. So what does that mean? It means when x is 3, y is 0. So x could equal 3, which means x minus 3 would have to give me 0. Here, x would equal 1. So x minus 1 would have to equal 0. So both x minus 1, again, and it was multiplicity 1, zeros as well. X minus 3 to the first, x minus 1 to the first on top. So I think I've taken care of the asymptotes, vertical asymptotes, and the x-intercepts. But the thing is, I can have some multiplier here. And right now what I have is I have a times x squared minus 3x minus 1x is b minus 4x plus 3 over x squared plus 2x minus 6x, that's minus 4x minus 12. Now, what other information do I need to finish this problem? Looking at a horizontal asymptote here that I've drawn in, and the horizontal asymptote is at y equals 2. But right now, if I take the highest power of the top and the highest power of the bottom, they're both x squared, so I will have a horizontal asymptote. And I divide them out. So right now, this is what we have. We have ax squared minus 4ax plus 3a divided by 1x squared minus 4x minus 12. Ignoring the earlier terms, I get ax squared over 1x squared. I get the horizontal asymptote as y equals a. We know it's y equals 2, therefore a has to equal 2. So we'll plug 2 up there to get our final answer. So this is where we are recently. R of x equals a times x minus 3, x minus 1 over x plus 2, x minus 6. And we just said a is 2. So I should be at r of x is 2 times x minus 3, x minus 1 over x plus 2, x minus 6. And let's distribute this out before we go to Desmos. R of x is 2 times x squared minus 3x minus 1x minus 4x plus 3 over x squared plus 2x minus 6x, that's minus 4x minus 12. So writing this in this form, 2x squared minus 8x plus 6 over x squared minus 4x minus 12. Let's see on Desmos if this graph agrees with what we had on the other page. Let's take a quick look at the other page first. Again, vertical asymptote at -2, vertical asymptote at 6, horizontal asymptote at y equals 2, x-intercepts at 1, 0, and at 3, 0. So back to Desmos we go. I don't see it. Back to Desmos we go. Okay, well, I guess I have to reestablish Desmos. Sorry about that. I'm going to go back to Desmos on my computer. There's the problem. Here we go. All right, so we're going to go ahead and graph that function. So I've got to take r of x equals upstairs. What do I have? 2x squared minus 8x plus 6. Downstairs, x squared minus 4x minus 12. So notice 1, 0, 3, 0 intercepts. Notice x equals -2. And x equals 6. As asymptotes. That looks pretty good. The y horizontal asymptote was y equals 2. And I'd say that looks pretty similar to what we had on the paper. Take a quick look back. And you can see that I believe we have successfully determined the equation for that graph.